Welcome. We are pleased to introduce Visual Chess, the first commercial project to successfully transform a traditional chessboard into an intelligent one, capable of capturing moves and transferring them to a computer. In this video, we will review the initial and only configuration process required by Visual Chess. This process must be completed whenever the software is used for the first time or whenever significant changes are made, such as repositioning the chessboard, changing the video camera, or modifying the lighting conditions. Visual Chess is software based on the optical detection of chess pieces on the board. For this reason, these factors are important and should be adjusted whenever necessary. In this example, we will demonstrate a real-world configuration scenario that could occur for any user of the software, including detection errors that will be corrected during the process. Understanding how the software operates is very important in order to avoid possible issues when detecting moves made on the chessboard. On its main screen, Visual Chess provides a configuration wizard consisting of 3 stages. The first stage corresponds to chessboard square detection, the second to light filter adjustment, and the third to the detection of the initial game position, whether playing with the white pieces or the black pieces. We begin by clicking the configuration wizard, which takes us to the first screen, where we must select the video camera currently connected to the computer that we wish to use, as well as its resolution. Using an extremely high resolution is not recommended, as it increases detection time. Likewise, a resolution that is too low may prevent the chessboard from being displayed correctly. As shown, the chessboard should be aligned according to the green guidelines. It is not strictly necessary for the board to match these guides perfectly. The objective is simply to achieve the best possible alignment with the video camera. Next, as shown in the reference image, we must move the 8 detection points to the corners indicated in the video. We may enlarge the image window to make this process easier. Once the 8 points have been positioned, we click Apply to verify how the board is being detected. In this case, some of the points must be adjusted to achieve the desired result, where all 64 squares are detected by the system and outlined with red lines. A certain degree of tolerance is allowed during this process, so the detection does not need to be perfectly exact. The most important aspect is that the 64 pieces in their starting positions remain, as much as possible, centered within their respective squares. Once this stage has been completed, we proceed to the second stage, which corresponds to the adjustment of the light filters. First, we have the filter called line filter, whose purpose is to detect the pieces on the board based on their shapes. As we adjust its value, we can observe that the noise present in the central squares gradually disappears. We refer to this noise as excessive light, and the objective is to eliminate it by adjusting the line filter. If this noise remains visible even after the filter reaches its maximum value, then we are dealing with a chessboard that exhibits light reflection, a condition we refer to as excessive light. This is a special case in which Visual Chess applies a specific configuration to those affected squares. For this purpose, we provide a dedicated instructional video that explains how to configure a chessboard affected by excessive light, as this situation may occur in certain cases. If this condition is present on your chessboard, we strongly recommend watching that video. If the line filter exceeds 95% and still fails to eliminate this noise, then the board falls into the special case described previously. It is not recommended to set the line filter above 90%, as doing so may affect the detection of the lines that define the chess pieces. We now move to the second filter, whose purpose is to detect only the black pieces. We adjust it as shown in the reference image, ensuring that the black pieces are properly highlighted in red. Finally, we have the brightness and contrast filter. Initially, its use is not recommended. However, it may be adjusted slightly to improve performance on boards affected by excessive light, and to help reduce the noise generated by this condition. Once this second stage has been completed, we proceed to the third and final stage, which corresponds to detecting the pieces in their initial game positions. We select the piece color and press Detect to begin the process. Visual Chess will perform a total of 5 detection attempts, highlighting any piece that cannot be correctly identified. In this example, several white and black pieces are not detected correctly. We then proceed to adjust the detection threshold values for both white and black pieces. It is highly recommended to review the information available for each of these settings. In general, these values should remain between 30% and 50%. Values outside this range are not recommended. As we can observe, even after adjusting these values, the detection is still not completely accurate. Therefore, we must return to the previous screen and further refine the light filter settings. In this case, we primarily adjust the black piece detection filter by slightly increasing its brightness. Small red reflections may appear on the bases of some white pieces, which is considered acceptable. We then perform the detection process again and observe that only a few white pieces still present detection errors. We therefore adjust the corresponding detection value. Finally, during its 5 analysis attempts, Visual Chess successfully detects all 32 pieces on the chessboard without errors and without any squares affected by excessive light. At this point, the chessboard and all of its pieces have been successfully detected. Initially, this process may appear somewhat complex or time-consuming. However, as you become familiar with the software, you will find that it becomes very simple to perform. It is not necessary to repeat this process constantly, but only when important factors such as the chessboard position, video camera, or lighting conditions have changed. At any point during a game, Visual Chess allows you to validate the squares and review all of the filters and parameters discussed throughout this process. Once the configuration has been completed, we proceed to finish the wizard. We can now observe that the 3 available ways of using Visual Chess have been enabled. Playing a practice game, playing a game between 2 players, or playing a game on a website. This concludes the initial configuration of Visual Chess. We invite you to explore our other instructional videos, and above all, enjoy the experience of using the software. Thank you very much for your attention, and we hope you enjoy using Visual Chess.